So we're going to work through the paper 21 for the May-June 2023 sitting. Our first question is telling us that CDE is a straight line. Find angle ADE. Right, so angle ADE would be this angle on the outskirts there. The surefire way of doing this would be to add up your internal angles. So 104 plus 71 plus 56. That should give me 11. 7 plus 5 will give me 12 plus 1. That's 13. And that would be 231. And then our next step would be to subtract the 231 from 360 because angles inside a quadrilateral add up to 360. 10 minus 1 will give me 9, 6 minus 4 will give me 2, and 3 minus 2 will give me 1. So the inner angle is 129 degrees. Finally, we say 180 minus 129 to give us 10 minus 9 is 1, 8 minus 3 is 5, 1 minus 1 is 0, to give us 51 degrees like that, because those two are angles on a straight line that add up to 180. Right, the next question. A train journey starts at 21:43 and takes 8 hours and 32 minutes. Find the time the journey finishes. Now, obviously, we can just punch this into our calculators if you have a Casio. But if you're going to be doing it manually, like I prefer to do, we just say 21:43 plus 8:32. 3 and 2 will give me 5, 4 and 3 will give me 7, 21 and 8 will give me 29. Right, now I know that my minutes are never above 60 or never above 59 actually. So I'm going to borrow 60 minutes from here and add an hour to the 29, which would leave me with 30 and 15. Again, still 30:15 is not a time that we would get on the clock. And because this has crossed over into the next day, I will simply say 30:15 minus 24 hours. 15 minus 0 would give me 15. And then 30 minus 24 would give me 6. So the time the journey finishes is 0615. Or you can write it as 6:15 a.m. Both answers are acceptable. Diagram shows a straight line intersecting two parallel lines. Find the value of A and the value of B, giving a geometrical reason for each answer. Now, A is going to be 58 degrees, simply because those are opposite angles. So opposite angles are equal. And B would be equal to, just lost my train of thought for a little while there. B would be equal to 180 minus 58, which should give us, let me write it down like that, 180 minus 58, 10 minus 8 is 2, 18 minus 5, that would become 6, 18 minus 6 is 12. So B is 122 degrees because these are co-interior angles and they add up to 180. Okay, so A and B are co-interior angles and they would add up to 180 degrees. By writing each number in the calculation correct to one significant figure, we need to find an estimate for the value of that sum. So obviously we start with the rounding off. 6.7 to one significant figure would just be 7. 2.1 would be 2. 18 would become 20 and 5.9 would become 6. So I'm going to have 14 over 14, which will just give me 1 as my final answer. Eric has 4 colors of paint. The probability that he uses each color is shown below. Find the value of X. Now we know that probability lies between 0 and 1. So to find the probability of x, it will be 1 minus 0.3 plus 0.35 plus 0.13. Okay, let me just quickly enter that into my calculator and see what answer we get. Alright, so after calculating, my final answer there would be 0.22. Question number 6. Find the volume of a sphere that has a diameter of 4.8 centimeters. We have been lucky enough to be given the actual formula for the volume of a sphere, so all we need to worry about is perfect substitution. So volume would be equal to 4 over 3 times pi times 4.8 to the power of 3. Again, after writing this down, you simply enter that into your calculator and we should get our final answer. So having entered that in, I get 463.01184. That's my answer in raw form, and we know that if they haven't specified the degree of accuracy that they would like, we always write it down to 3 significant figures, which should give me 463 cubic centimeters. Right, next question. The scale of a map is 1:125,000. On a map, the length of an island is 9.4 centimeters. Find the actual length of the island, giving your answer in kilometers. So our scale is very direct. It will be 9.4 times 125,000, which is giving me 1,175,000, and it wants the answer in kilometers, so we're going to divide that 1,175,000 by 1,000, because these are centimeters, isn't it? Okay, so actually going to divide that by 10,000, because 100 meters is equal to, sorry, I got a little tongue-tied there. 100 centimeters will give me 1 meter, and then 1,000 meters will give me 1 kilometer, isn't it? So from centimeters to kilometers, I need to multiply my 100 times my 1,000. So I'm actually dividing by 100,000. Now these 3 zeros are going to cancel each other out, and then I have 1,175 divided by 100. I can just move this 2 points back, and we should have 11.75 kilometers. 11.75 kilometers. That should be our final answer there. Right, the nth term of a sequence is 10 minus n squared. Write down the first 3 terms of this sequence. Very easy again, we just substitute n is equal to 1 for our first term, n is equal to 2 for our second term, and n is equal to 3 for our third term. So 10 minus 1 squared should give me 9. That's my first term. 10 minus 2 squared should give me 6. And 10 minus 3 squared should give me 1. So my terms are 9, 6, and 1 in that order. The next question is telling me that these are the first 4 terms of another sequence, 7, 10, 13, and 16. Find an expression for the nth term of this sequence. So this one is pretty straightforward. First of all, I'm going to find the difference between each term. That is adding 3. And then here we're adding 3 again, and there we're adding 3 again. So we have a common difference between each of our terms. The next step is that I'm going to find a constant that makes everything work, because my general nth term equation for a sequence like this would be dn plus c, where d is the common difference. I already have that. So now I need to substitute so I can find my c. So I will use the first term. 7 is equal to 3 times 1 plus c. 3 times 1 is just 3, so 7 minus 3 is equal to C, meaning that my C is equal to 4. So finally, my nth term sequence would be 3n plus 4. As simple as that. Right, question number 9. Triangle ABC is similar to DEF. Find the value of H. Okay, so because our triangles are similar, there must be a scale factor that one triangle is using to move on to the next one. So I am going to find corresponding sides. BC for me corresponds to EF. So I will say that EF over BC is equal to DF, which is our H that we're looking for, over AC. And then obviously substitute with the values that I have. I will have 8.1 over 7.2 is equal to H over 5.6. If we do a bit of rearranging, we will have 7.2H is equal to 8.1 times 5.6. And then finally, my H, sorry, the working is all over the place, would be equal to 8.1 times 5.6, everything divided by 7.2. So I'm going to enter that into the calculator and see what I get. So after working out, my final answer there is 6.3 centimeters. Number 10, without using a calculator, work that sum out. First step is to convert my mixed fraction into an improper fraction, just so that it's easier to work with. So 7 times 2 will give me 14, plus 1 will give me 15. So I'm going to have 15 over 7 divided by 5 over 9. The next step is to change and flip. I'm going to change my division sign to a multiplication sign and then flip this fraction on the right. So I will have 15 over 7 times 9 over 5. And then if I cross cancel or cross divide, 5 into 5 will give me 1. 5 into 15 will give me 3. Finally, 3 times 9 is 27 over 7. Now 7 goes into 27 3 times, and there is a remainder there of 6 over 7. So my final fraction is 3 and 6 over 7. Okay, I'm going to flip the screen a bit for this one so that I have everything in perspective. It may zoom out a little bit. Apologies for that. Describe a single transformation that maps triangle A onto triangle B. So that there is definitely an enlargement. With a scale factor of 1, 2, 1, 2, 3, 4, with a scale factor of 2, and center of enlargement. Let us work that out. So for the center of enlargement, I just like to join points that are the same. So those 2 points match up. That. Okay, my lines are a bit crooked because I am freehanding them, but in your exam, be sure to use a ruler. So there's that. And then, I keep making a mistake with that one. There we go. All right. And then there's this one having to match up with that one. Okay, so I would guess that if my lines were drawn perfectly, they would meet up at the point 0, 7, and that would be the center of enlargement there. Okay, now we need to map triangle A onto C. Triangle A onto C, that is definitely a rotation. And that would be for me a clockwise rotation of 90 degrees. Okay, so I'm just writing the keywords here, but as long as you have these keywords showing up, you will be fine. Rotation clockwise of 90 degrees with center. And now I'm going to figure out the center of rotation. Okay, so for the center of rotation, I'm going to look for a point that is 90 degrees and also an equal distance from both points on my triangles. I usually just eyeball this, but by looking at this, I can tell that if I start from this point going down, and then if I start from that point also meeting there, they're exactly the same distance. So I would put my center of rotation there at 3, 1. Like that. Okay, let's move on. Let me flip back the screen. We don't need the small screen anymore. AO, OB, and OC are all radii of the circle. AB is equal to BC. Therefore, triangle AOB is congruent to triangle COB, drawing around the correct criterion for this statement. So when we're looking for the criterion for congruency, we have to look for what makes these triangles congruent. Do they have angles in common? Do they have sides in common? Or do they have a combination of angles and sides in common? So we have triangle AOB, AOB like that. And then we have COB. Okay. That's the direction in which they are moving in. So it would mean that my side, let me just clear that up. It would mean that my side CO, okay, corresponds directly to my side AO, okay. Then if you follow that pattern, they both share the side OB, and then finally side BC corresponds to side BA. Therefore, I would say the criterion here is side, side, side. Okay, let's move on to the next one. P, Q, R, and S are points on the circle, and TQU is a tangent to the circle at Q. PR and SQ intersect at the center of the circle O, and PQ is parallel to SR. Angle RQU is 42 degrees. Calculate angle QSR. Okay. QSR, let's map that out first. QSR. Okay, so it would be this angle V. Now, I think we actually don't need to have any actual calculations. It actually is pretty obvious. So we have our angle 42 degrees RQU on the outside there, and that angle is sitting on a chord and a tangent. So an interior, opposite interior angle that sits on the same chord as another angle on the outside that sits on a tangent are actually equal. Therefore, all we're saying in a nutshell is that QSR is also 42 degrees. Like that. Okay, let's move on to the next one. I'm going to have to flip the screen so that we have everything in perspective. Angle PQS. Zoom in just a little bit. Angle PQS. Okay, that one is very straightforward. PQS forms a Z angle with angle RSQ, so that is also 42 degrees, as simple as that. Right, finally we have angle POS. Right, we have angle POS there. POS is an angle at the center. We can see that it is formulated. Okay, all right, okay. So POS is double the size of PQS. all right, because they are sitting or they are subtended by the same arc. So we know that an angle at the center is double an angle at the circumference when they are subtended by the same chord or the same arc. Therefore, our angle POS is going to be 84 degrees, like that. Okay, let's flip back and move on with our paper. Anya invests $6,000 in an account that pays compound interest at a rate of R% per year. At the end of 8 years, the account has earned $621.70 in interest. Calculate the rate. Okay, so I like to start by writing out my equation. Compound interest is equal to principal multiplying 1 plus R over 100, okay, to the power of time. And then we fill in what we have. So pays compound interest at that rate there. Our principal is 6,000, okay, times, open bracket, 1 plus R over 100. That is what we're looking for, to the power of time. And our time in this case is 8 years at the top there, like that. Okay, nicely done. And then for our compound interest, it's going to be the 6,000 plus the 621.70. So I'm just going to add those to give me $6,621.70, like that. So now we rearrange everything to make sure that R is the subject. I'm going to start by taking this 6,000 over to that side. So I'm going to have 6,621.70 divided by 6,000 is equal to 1 plus R over 100 to the power of 8. Now for me to remove that power, I can invoke the 8th root. So the 8th root of 6,621.70 over 6,000 is equal to 1 plus R over 100. And then finally, all I want there is the 1 plus R over 100. So I will have, or rather, let me simplify it. So let me just enter that into my calculator, because I've written it so big I've run out of space. I'm just going to simplify and then come back with the answer, and we'll continue from there. All right, having done some calculation there, I will end up with the 8th root of 1.1036. I'm just going to write out as much as I can. Be equal to 1 plus R over 100. Then we're going to take this 1 over to the opposite side. So the 8th root of 1.1036 minus 1 is equal to R over 100. Finally, to have just the R on its own, we multiply, cross multiply both sides. So R, our rate, will be equal to the 8th root of 1.1036 minus 1. All of this multiplied by 100. And when we enter all of that in our calculators, just give me a second. I like to keep my numbers as raw as possible so that my final answer isn't affected too much. I am going to get 1.240. And to three significant figures, I'm just going to write that down as 1.24%. Okay, so that is our final answer there. Okay, next one, y is directly proportional to the square of x plus 3. So y is directly proportional to the square of x plus 3. Okay, when x is equal to 2, y is equal to 5. Now for me to remove my proportionality sign, I say y is equal to some constant multiplying x plus 3 squared. And we have the values of x and y, so 5 is equal to k times 2 plus 3 squared. 5 is equal to k times 5 squared, which is 25. So 5 is equal to k times 25, which means that k, therefore, k is equal to 5 over 25, which is 1/5, like that. Now, finally, having found my k, I can resubstitute that to get the value of y. So we say that y is equal to k, and then that's multiplying x plus 3 squared. Y is equal to 1 over 5, multiplying, my x in this case is 1, plus 3 squared. Y is equal to 1 over 5 times 4 squared, which is 16, which would be 16 over 5. And if I am to simplify that, I would end up with 3, 2. Okay, so my y is going to be 3, 2, like that. Right, the bag contains 5 green buttons, 2 blue ones, and 6 white buttons. Maya takes 2 buttons at random from the bag without replacement, and the probability that one button is green and the other button is not green. Okay, now to find the probability that a button is green, we have a total of 5 plus 2, that's 7 plus 6. So we have a total of 13 buttons. That's our total there. And the probability of picking a green button the first time around is 5 over 13. Now, because we haven't replaced it, it means we now have 12 buttons in our bag. And the probability of picking a button that is not green would be blue and white combined together, which is 2 plus 6 to give me 8. And we have, what do you call this? We have 12 buttons in the bag now. So that would be 8 over 12, like that. Okay, and then because, let's multiply that out first, sorry. 5 times 8 will give us 40, and 13 times 12, let me just punch that into the calculator. All right, so we have 40 over 156. Now, because this can also happen in the opposite direction, we can multiply that by 2 to give us 80 over 156. And then if we reduce that to the lowest terms, we should get, if we divide this by, okay, if we divide it by 4, we should reduce that to lower terms, and we will get 20 over 39 as our final answer there. Right, find the magnitude of a vector that has minus 4, 5. Okay, so for our magnitude there, we will have minus 4 squared plus 5 squared. Minus 4 squared is 16, 5 squared is 25. 16 plus 25 will give me, my mental math has just disappeared. That should give me 41, and then I find the square root of that. So let me do the working out. Right, square root of 41, if I round that off to 3 significant figures, is going to give me 6.40. There we go. Okay, B, the diagram shows triangle OAC. A is the midpoint of the straight line OB. OA is equal to X and OC is equal to Y. Find CB in terms of X and Y. So I like to draw in my vectors so that I have a feel of what we are actually trying to find there. So we're trying to find CB in terms of A and Y. A is the midpoint of the straight line OB. So it means that this value there is also X. If it's the midpoint, it's halfway through. Okay, so I'm just going to write that down. OB is equal to 2x, okay? And then, so for me to get to CB, that would be equal to OB minus OC. Yes, CB will be OB minus OC, which is 2x minus y. So I'm going to write it down here, 2x minus y. Simple as that. Okay, we have a simplification, 81x to the power of 12 raised to the power of 3 over 4. Okay, so I like to break everything down, so I will have 81 to the power of 3 over 4 times x to the power of 12 multiplying 3 over 4 like that. Okay, nicely done. Then I would have here the fourth root of 81. My mind is moving faster than my pen. Of 81 to the power of 3 multiplying this times that will cancel out, and I will have 3x to the power of 9 like that. Okay, so I'm just going to enter that into my calculator, but I do believe that the fourth root of 81 should be 3. But let me confirm. Okay, yes, the fourth root of 81 is 3. 3 to the power of 3 will give me 27. So here I will have 27 and x to the power of 9. So my final answer is 27x to the power of 9. The diagram shows the positions of 3 towns, U, V, and W. Calculate the bearing of U from W. Okay, so W is over there and U is over there. So from W, we are going to move in a clockwise direction, and that there is the angle that we are looking for. So just to fill in information on the diagram, angle UVW, which is this guy over there, is 125 degrees. Okay, so we can find the length bearing of U from W. So we can start by finding this inside angle, or this angle here at the corner there, angle UWV, using the sine rule. So my sine rule is going to tell me that A over sine A is equal to B over sine B. I will have my 62.4, okay, over sine 125 degrees is equal to 27.3 over sine B, like that. Okay, I'm going to cross multiply that to make sine B our subject. So sine B would be equal to 27.3 times sine 125 degrees, everything divided by 62.4, and then we can use our calculators to find that answer. Right, so sine B is equal to 0.3583, and B would be the arcsine of that, 0.3583, like that. Right, after doing the calculations, our B is 20.99 degrees. Just changed up the color so that we don't get lost in our work. Okay, so we found that this part here is 20.99. In fact, I'm just going to round it up, 21 degrees, like that. Okay, again, we're looking for that whole wide angle, so I will actually go on to just extend that. Lines are not straight. There we go, much better. And I'm also going to extend that so we can manipulate the rules of angles that we know. Now I know for a fact that this would be 180 degrees minus 125, which should give me 55 degrees there. And if that is 55 degrees, it means the entirety of this angle that I've written in red is also 55 degrees. Okay, and it would mean what is actually important rather is this missing piece. From 90 degrees, this would be 35 degrees, like that. Okay, so now we can add up all these degrees so that we get our bearing. So I have 90 over here, I have 90 over here, I have 35, and I have 21. So 90 plus 90 plus 35 plus 21, that should give me 236 degrees, and that there is the bearing of our angle. Okay, so we're going to write our answer down here. We had all the space that we didn't use, but oh well, 236 degrees, like that. Okay, next question on the diagram. Sketch the graph of y is equal to cos x for the range of 0 to 360 degrees. Okay, so my cosine diagram will obviously start at the top there, my 1 here. So I will have this. Okay, so just activate my pencil. So this should be that point, just so that I can get my sketches as accurate as possible. That will be over my 360, like that. Then my first point is here. Okay. So my sketch is going to go like that, and then pass through the middle, and that there, and then continue through as much of that as possible. It's a sketch, it will fly. We just need the basics, isn't it? Solve the equation 5 cosine x plus 3 is equal to 0 for 0 is less than or equal to, okay, for that range there. Right, so just going to write that out. 5 cosine of x plus 3 is equal to 0. 5 cosine of x is equal to minus 3. I'm going to take the 3 over to that side, and then we're going to have cosine of x is equal to minus 3 over 5, and x would be equal to the arc cos of minus 3 over 5, like that. Okay, let's find out our first value of x within those limits. Right, so the first value of x that I get will be 126.86. I'm going to round that off to just give me 126.9, because my angles usually have a degree of accuracy of 1 decimal place. Okay, then now we need to find the other angle, which will be as simple as saying 360 minus 126.9, and so punching that into my calculator, I will get 233.1, and those are my two angles there. Okay, table shows some values for y is equal to 3x squared minus 2x minus 1. So again, this is just substitution when completing our table of values. Okay, we only have two values missing there. So the first one will be 3, open bracket, minus 0.5 to the power of 2 minus 2, open bracket, minus 0.5 minus 1. And if I enter that into the calculator, I should get 0.75. I'm going to do the same thing with a positive value of 0.5. And when I enter that into the calculator, I should get minus 1.25, like that. Okay, so my table is complete. Very straightforward substitution there. Now we have to draw the graph that is expected there. So I'm going to flip it over so that I have my values as well as I enter into the graph. So the first one, x is -1 and y is 4. Okay, so that's right at the top there. The next point, x is minus 0.5 and y is 0.75. So this would be 0.5. I would gauge my 0.6, 0.5, 0.6, 6.5, 7, 7.5. So that would be somewhere in the middle. So we have minus 0.5 and 0.75, so 6, 7. That would be in the middle right there. And then the next one is 0 and -1, which is over here. Okay. Then we have 0.5 and -1.25. So 0.5, so -1, 2, 2.5 right there. 1 and 0 there. And then finally we have 1.5 and 2.75, which is 2.567 right there. Okay. Having drawn all of this, I am going to join this together to get as accurate a curve as I can. Right, bear with me if my line is not straight. I have tried my level best, but we should have something along these lines. Alright, by drawing a suitable straight line, solve the equation of 3x squared minus 4x minus 2 is equal to 0 for the range of -1 to 1.5. Okay, so you first have to figure out the equation of the line. 3x squared minus 4x is equal to 0. So this means at that point, our y is equal to 0. So I just scrolled back up real quick to get my original equation, and that was 3x squared minus 2x minus 1. That was my original equation, and I'm going to equate it to this new one because at those 2 points, that's when our equations are equal. So that would be 3x squared minus 4x minus 2, like that. And all of this is subsequently equal to y, right? So I'm just going to group them so I don't have two pairs of equations hanging over me. So I'll bring all of these guys to that side. So I will have 3x squared minus 3x squared minus 2x plus 4x, and then minus 1 plus 2, all of this equal to y. And if I simplify, 3x squared and 3x squared will cancel each other out. Minus 2 plus 4 will give me 2x. And then minus 1 plus 2 will give me plus 1. Yes, okay. So my equation is going to be y is equal to 2x plus 1. And this is what I'm going to use to draw my suitable straight line. So to get my first pair of coordinates for the straight line, I am going to make x 0. When x is 0, when x is equal to 0, y is equal to 1, according to this box there. And then when y is equal to 0, x will be equal to, so we will have minus 1 over there, and then x will be equal to minus 0.5. Okay, and let's go back to the top with this information. Let's flip it over. Okay, so when x is 0, y is equal to 1. So we're going to plot that point, 0, 1, which is that one. And then when y is 0, x is minus 0.5. So minus 0.5 and 0, which is over there. And then I am going to draw a straight line. Maybe let me change up the color of this line just to make it easier. Let's make it green so that our line is more apparent. It's not what we're looking for. Let's zoom in. Okay, there we go. I'm going to join those 2 points. in as straight a line as possible. Okay, it's the best that I could do. And then we are going to look for the points where that line cuts the graph, which is somewhere here at minus 0. Looks about to be at minus 0.4 thereabouts from my graph. 0.4, 0.35, so the value of x there is minus 0.35, like that. It's somewhere in between. It's not quite where it's supposed to be. Okay, let's move on to number 21. I think this should be our last question. Okay. Is that off? A curve has the equation y is equal to x cubed minus 12x. Find the gradient of the curve at the point minus 1, 1. Okay, so first thing that we're obviously going to have to do here is differentiate our curve so that we find the gradient of the curve. The differential of the curve is its gradient. So dy over dx will be equal to 3x squared minus 12. Okay, that's the differential of our graph there. And it says the gradient of the curve is at the point 1 minus 11. So I am going to substitute there my x value as 1. So from here, I will get 3, 1 squared minus 12. 3 times 1 squared is just 3, minus 12 will give me minus 9. And that should be my final answer. There we go. Right, find the coordinates of the turning points of the curve. Right, now we want to find the coordinates of the turning point. We already have our gradient, so that shouldn't be too difficult. We know that at our gradient, our turning points or stationary points for dy over dx will be equal to 0, or at dy over dx will be equal to 0. So we have 3x squared minus 12 is equal to 0 at this point, and then we are going to simplify that so that we actually get our turning point. Right, looking at this, I'm going to factor out 3, and I'll end up with x squared minus 4, like that, is equal to 0. Okay, so this means that definitely 3 can't be equal to 0, so that is out. So my x squared minus 4 is what is possibly equal to 0, and I can solve that using the difference of two squares to give me 3x plus 2, and x minus 2 is equal to 0. So my x is either minus 2 or 2, like that. So I'm going to fill in the values of my x there. So I'm going to put in minus 2 here, and then I'm going to put positive 2. And then we're going to go back to our original equation to find the y values. Original equation, y is equal to x cubed minus 12x. Y is equal to x cubed minus 12x. So for my first x, that is minus 2, I will have minus 2 cubed minus 12 times minus 2, which should give me minus 2 cubed will give me minus 8, and minus 12 minus 2 will give me plus 24. 24 minus 8 will give me 16, if I'm not mistaken. So when my x is minus 2, my y is going to be 16. Let's write that down. Okay, then when my x is positive 2, I'm going to substitute that now. Here I will have 2 to the power of 3 minus 12 times 2, which will be 8 minus 24, and that will give me a minus 16. So those there are the coordinates of my turning points or stationary points. That is our last question. I hope this was very clear. If you have any questions, still feel free to contact me.